Hello everyone, welcome to the 8th lecture in this series. In this lecture, we are going to learn about another data structure named linked list. It is also an abstract data type. So, we will be learning this data structure along with the operations that are permissible on this data structure. And we will be learning first what are all its types, how to create a list and how to do the very basic operation on this list, namely the traversal operation. So, this is going to be the organization of this presentation. We will be learning what linked list is and its features. Then we will compare and contrast arrays and linked list, and then we will be studying the types of list, namely single, double and circular linked list. And then we learn how to create one node list and then how to create a collection of nodes and make up a chain of list. And finally, we will be learning about the traversal operation on a single linked list. So, first the definition for linked list. It is a data structure. It falls under the category of dynamic data structure. It is a dynamic and linear data structure as such. So, we have a collection of elements, and we call it as this data structure as dynamic just because we allocate memory at the time when it is required, and we will be freeing up the memory allocated associated with this data structure whenever we do not want that. So, we say that linked list is a dynamic data structure. So, here as such when we talk of memory allocation, memory is allocated at random locations, but we actually create a sequence of elements and make it as a list with the help of pointers, and we create a chain by actually doing some assignments as we saw before with the previous lecture. And the main purpose of having this data structure is that we encountered some problems with the first data structure which we learned, namely arrays. Consider that we have allocated an array with 100 elements. So, we assume that the array is of type integer. So, in that case for 100 elements, and since it is of type integer, so my system will be allocating 4 bytes. So, altogether 100 into 4, 400 bytes would be allocated for that array at the time of compilation. If suppose I actually store only 5 elements in that array, so 5 into 4, 20 bytes is my requirement, but I have allocated 400 bytes assuming that I may require in future. So, here in that case actual usage is 20 bytes, but allotted is 400 bytes. So, the other 380 bytes is a huge wastage of storage, and that is one of the drawbacks of arrays. And the other case which we can assume is that we have allocated array with 100 elements and we want to store the 101th element in that array. In that case, expansion of size is not possible with respect to arrays. So, these two scenarios actually actually show us the drawback which we encounter with arrays. Just because array being static, it does not permit us to either shrink or expand the size once allocation is done. The other problem which we encountered with arrays is that we learnt with the insertion and deletion operations in the earlier lectures that if you want to either insert a new element or to delete an element from an array, then we have to shift up all other elements either upwards or downwards, and that takes up additional amount of time. So, all these all these disadvantages are actually overcome by this data structure named linked list, as here we do not allocate memory contiguously, but we actually chain up all the nodes with the help of pointers. So, what you see here is a linked list with 4 elements, namely A1, A2, A3 and A4, and of course, we do not estimate the size of the list ahead. As and when required, we request the system to allocate memory for each of these elements, and thereby we have allocated memory for every element in this list as and when required, and we have created a chain of arrangement of this list by making some pointer assignment. We have made the pointer in A1 to point to A2, and similarly the next portion of A2 to point to A3. Likewise, we have created a chain like arrangement, and of course they are all dispersed in different locations in memory. And in order to mark the beginning of this list, we have designated one pointer named head, and we have made that head pointer to point to the first element in that list. And in order to mark the end of that list, what we have done is we have denoted we have made A4 to be the last element of that list, and in its address portion we have stored a value of null, and having a value of null marks the end of the single linked list. So, these are certain other features of linked list. So, in a linked list we will have a pointer named head or header that will be usually pointing to the first node in that list. So, as I said before, all the elements in a linked list will be dispersed throughout the memory or in available at different locations in memory. So, intentionally we should have we should keep track of the first element in that list with the help of a head or header pointer. And in order to create a chain of elements, successive nodes have to be linked or connected by means of pointers. And in order to mark the end of the linked list, we will be having or assigning a value of null to the last element in that list. And linked list gives us the flexibility to shrink or expand the size of the list during the execution of the program, and we can make the list to be as long as we require, and there is no wastage of space with respect to linked list, just because we will be allocating memory only when we require, and we will be freeing up the space whenever we feel we no longer require that particular element in our list. So, this is one slide which tells you or which provides us a way for comparing arrays and linked list. With array, we know for all the elements memory is allocated at contiguous memory locations. An array falls under the category of static data structure, and which means we allocate memory for arrays at the time of compilation. So, this makes arrays to be suitable for maybe inserting and deleting an element at the end position. You know, it takes time complexity of order of 1, and if you want to randomly access any element in that array, in that case also array is suitable. And if you want to search for a particular value, in that case also an array would be fit. And there are certain other cases in which linked list is preferable. So, linked list, you know, the elements are all available at different or random locations in memory, and they are made to be adjacent with the help of pointers, and it falls under the category of a dynamic data structure where memory is allocated at runtime, and linked list is suitable for inserting elements at any position and deleting elements from any position, and applications where sequential access is required, we will be able to do that with the help of navigating through the pointers. So, in situations where we are not sure how many elements the list is going to contain, we can very well go ahead with linked list. Thereby, we will be saving a lot of memory space. These are the types of linked list. One is single linked list, double linked list, and a circular linked list. And of course, in the next slides, I will be explaining what single, double, and circular linked list are. So, here what you see is a single linked list. So, in a single linked list, we will be having one pointer designated as head that will contain the address of the first element in that list. We will be having one node to be the last node of that list. The speciality of the last node is that its address part will contain a value of null. For all other elements other than the last element in the list, every element will be pointing to its successor, that is node A will contain the address of node B, the next portion of node B will contain the address of node C, and likewise as here, since C happens to be the last node in that list, its address contains a value of null, and that marks the end of the list. So, the second type of linked list is double linked list. So, the name itself conveys you the meaning. In a double linked list, we will have two pointers, one pointing to the node following it and one pointing to the node preceding it. So, pointers exist in both the directions to adjacent nodes in a double linked list. This makes double linked list special. We can traverse the double linked list in both the directions, that is in the forward direction by by navigating with the next pointer, and in the backward direction by navigating following the previous pointer. And in a double linked list, we can usually designate two pointers, namely head to point to the first node in the list, and we may even have a pointer named tail to point to the last node in that list. And the thing to be noted here is that node A has a next pointer that points to the address of B, and node A has a previous pointer. Since node A happens to be the first pointer, its previous pointer's value would be null. Similarly, when we take into account the node B's next pointer would point to C, and node B's previous pointer would point to A. And when I take into account the node C, its previous pointer would point to B and its next pointer would point to null, just because C happens to be the last node in the double linked list. So, with the help of forward pointer, that is next, I can move in the forward direction in the list, and by navigating with the help of previous pointer, I can go or traverse the list in the backward direction. So, that makes double linked list special over the other two types of lists. The third type of linked list is a circular linked list. So, here the circular linked list which you see here is much similar to the single linked list, except that the last node in the circular linked list, instead of having a value of null, it points to the first node in that list. So, that makes circular linked list special. We need not even have one node to be one pointer to point to the first node in this list. So, in a circular linked list, we can traverse through the list from any position in that list. So, here in a circular linked list, we will have a pointer, the last node will have a pointer to the first element in that list, and there is no starting or ending point for a circular linked list, and it can be traversed from any node in the list. And these are some of the advantages and disadvantages of single and double linked list. So, in case of double linked list, the advantage is that, as I mentioned before, we can traverse in both the directions, that is forward and backward. And when we talk of disadvantage of double linked list, the only disadvantage is the extra space requirement for maintaining additional pointer. As I said before, every node will have two pointers, one to the node following it and one to the node preceding it. So, maintaining the additional pointer may require some extra space, and of course, whenever we do any operation on such a list, we may have to make appropriate assignments to those two pointers, and that happens to be additional complexity with respect to double linked list. So, now we learn how to define a node in a single linked list. So, when we talk of implementing a single linked list, first and foremost we should know how to define a node in a single linked list, and once we know how to define a node, then we can create a collection of nodes, and then we could chain up those nodes to form a linked list. So, this is going to be the node definition for a single linked list. We define a structure named node. We have two members for that structure. One happens to be data of type integer, that is of course used to store the values you see here like 10, 20 and 30, and we have another member called next, which is a pointer, and as you know, its type is struct node, which means it is a self referential structure. So, we have whenever we define and create a variable for this structure, it would look like this. It will have a data part and it will have an address part named next, and this address part, of course, when we chain, it will be pointing to the next node in that list. So, when we create a one node list, we usually make next to hold a value of null and data may hold any value as you wish. So, here you have a node definition for a double linked list. So, the only difference is that only difference of a double linked list node definition from a single linked list is that in a double linked list nodes definition, we will have two pointers, one named next and one named previous. Next is meant to point to the node following and previous is meant to point to the node that is preceding it. And apart from that, there is one data portion to hold some value which is part of this list. Now, we learn how to create one node in a single linked list. So, in order to create one node in a linked list, first of all we have to reserve memory for this node. So, as I said before, linked list falls under the category of dynamic data structure. So, we have to request memory for one node at runtime with the help of malloc function. So, malloc of size of struct node. So, we are asking the system to reserve memory for one node whose size is of whose memory requirement is that of the structure definition which you made before. And you want that pointer to be of this structure type. So, we say that we make an explicit conversion here that the pointer it returns as a part of malloc function should be of type struct node star, and the name which we give for this pointer is new node. Now, as such, when we execute this one statement, we will have memory allocated for one node, and that new node will have a data part and a next part, and whatever value you want to put in, we will be putting in the data part. And initially, as I said before, when we create a one node list, its address part would be usually assigned to a value of null. Since this happens to be the first node in that list, what we have to do is we have to set up a pointer named header, and the purpose of this header pointer is to point to the first node in your list. Now, the first node is named as new node. So, we make an assignment of this form, that is header is equal to new node, which means the address of this node is put up in header pointer. And after that, what we have to do is, in order to facilitate further node creation, we assign whatever we have in new node to temp. Thereby, we make the pointer temp to point to this new node. So, this is how we create a one node list. So, how to create a chain of nodes and to make up a single linked list is that, first of all, you need to decide how many new nodes have to be created. Then we may have to allocate allocate memory for each of those new nodes one by one. Then we have to read data for each of those new nodes, and finally we have to chain up all those new nodes so that we have a linked list at the end. So, the first three lines I hope you would be knowing now. We have allocated memory for every node, we have placed the data in the data portion, and in every new node's next spot we will place a value of null initially. So, once we have done, what we do is that we put up an assignment of this form temp next is equal to new node. So, you know, before earlier itself we have set we have made the new node as temp, right. So, the temp is a pointer pointing to this node. So, hereafter we will be referring to this node by the name by the pointer temp, right. So, as soon as once we have created a one node list, now we have created a new node by name new node. So, we put up the new node in we put up the new node as a node next to temp. So, we put temp's next is equivalent to new node, thereby we make new node next to the pointer next to the node that is being pointed to by temp. After that, what we have to do is we have to advance temp by one position. So, whatever is new node now will be temp hereafter. So, for that we make an assignment of this form temp is equal to temp's next. So, now earlier this was temp, by this statement what will happen is that hereafter 200 will become temp. So, next time I may allocate memory for 50, at that time 50 will become temp, and finally when I allocate memory for 30, this is my new node, and finally I make temp to move to this position with the help of temp is equal to temp next. And since 30 happens to be the last node in my list, its address part would be left as null. So, this is how when we put up these statements in a loop, that will facilitate us to create a chain of nodes of this form, and that makes up a single linked list. So, having seen how to create a one node list and having seen how to make up a chain of lists, now we actually see the routine to create a single linked list. So, I hope by this time you understand the purpose of every line here. We define two pointers, new node and temp, both of type struct node, and then we have two variables data and I. So, first we check we allocate memory dynamically, and the pointer returned to is new node. We check whether the memory allocation was successful or not with the help of if new node is equal to null. If memory allocation was unsuccessful, it would have returned null instead of this pointer holding some address. So, here if null, we say that memory allocation was unsuccessful, otherwise it means allocation was successful. So, we enter data, we ask for data, we put data in the data part, we put address as null. First we create a one node list. So, at that time header would be pointing to this new node, and then we make temp to point to this new node again. And the rest of the things, whatever we saw before in the to create a chain of list is put up actually in a loop. So, that many how many, depending upon the value you specify for n, that many times malloc would be called, and we will be creating that many new nodes, and we will be making assignments of this form. We put up data in the data part, we put up next in the null, and then we create a chain with the help of these two statements like temps next is equal to new node and temp is equal to temp next. Thereby we will be creating a chain of nodes which actually make up the single linked list. Since linked list is an abstract data type, we will just have a look at what are all the operations that are permissible on a linked list. Like we can traverse a list, and we can use the traversal operation to find the minimum element in a list or maximum element in a list, etc. Or even we can print all the elements in a linked list. And then just as we studied for arrays, we can do insertion operation on a list, and that to all the positions like front, middle and end. And likewise we can do deletion operation on a list at all the three positions, and then we can do a comparison of two linked lists. Then we can even merge two linked lists into one large list, and then we can even do the search operation and sorting operation on a linked list. So, all these operations are permissible on a linked list, and all these operations together with this data structure make up the linked list ADT. So, now we will be seeing one of the basic operations on a single linked list, namely traversal. So, here by traversal we mean from start till end we will be navigating through the list. So, in order to know the start of that list, we need to know the value held in the header pointer. So, this is the difference of linked list from arrays. Earlier for sure in arrays that a of 0 is going to be the first element in that array, right. Whereas in case of linked list, as I said before, for every element memory is allocated at random locations, and we only mark the beginning of the list by making a pointer named header to contain the first element of the list. So, in order to do a traversal operation, first of all you need to know from where to start, but that can be done by accessing the header pointer. After that, once you know the header pointer, that gives you the address of the first node in that list, and the first node will contain the address of the second. Likewise, we will be able to navigate through the entire list, and we will be stopping at the point where the next pointer points to null, which means that marks the end of the list. So, here what you see is we have a function named traverse list. We pass that function an argument, the header pointer, which is the first node in that list. So the traverse list function takes as an input the header pointer, which is the pointer to the first node in that list. So in order to do a traversal operation, the first condition which we check is that whether header is null or not. If header is null, it means your linked list is empty, which means there is no nodes in that list. Otherwise, it means if header is not null, it means the list contains some elements. So what we do is we make an assignment of this form, that whatever value held in header, we assign that to temp. So now temp will be pointing to the first node in that list. Now what we have to do is we have to visit every node in that list till temp is null. When temp is null, it means we have reached the end of list. So we check whether temp is not null. So initially we have assigned header to temp, which means temp now points to the first element in that list. Then I make a check whether temp is not null. Of course it will not be null. So what I do is I just print whatever data that is in temp, and after that what I should do is I should go to the next element in that list. In order to make a jump to the next element, what I do is I advance temp to the next position. In order to advance temp to the next position, I just follow the value held in next. So I make temp as temp's next. So thereby I move to the next element in the list. Then I make a check whether temp is not equal to null. If suppose I have a second element in the list, then temp will not be null. So I print its data. Then I move to the third node in the list. So I will be keeping on moving till I reach a point in time where temp is null. So that marks the end of that list, and by that we put an end to this traversal operation. So far we have seen some of the basic concepts associated with linked list. You know, linked list is a data structure where we have a collection of elements called nodes, and as such in principle for a linked list, for different elements memory is allocated at different locations, and of course we chain up all those memory locations with the help of pointers and create a sequence, and we call it by the name linked list. And there are different types of linked list, namely single linked list, double linked list, and circular linked list. In a single linked list, every node will have only one pointer, and that pointer will be pointing to the next node in that sequence. And in case of single linked list, there will be one node named header. There will be one pointer named header which points to the first node in that list. And in a single linked list, we can travel in only one direction, that is from first to last. The second type of linked list is double linked list, in which every node will have two pointers, one to the node following it and one to the node preceding it. So that makes a double linked list bidirectional, and we can traverse in both the directions. And the third kind of linked list is a circular linked list. In case of circular linked list, the difference of circular linked list from single linked list is that in single linked list the last node's address would be null, whereas in case of circular linked list the last node would point to the first node in that list. And the advantage of linked list is that it is dynamic in nature. So anytime I can expand its size or shrink its size. And we learnt about two operations on a linked list. One is creation. So we learnt how to use malloc functions and to allocate memory for every node dynamically, and how to link each of those new nodes with the help of pointers. And then we studied about other operation on linked list, namely traversal, which with which we learned how to move from the head node in the list to all other nodes in the list. So we sequentially moved from one node to next with the help of traversal operation. So having learnt the concept of linked list and some of its types and operations, let's test our understanding of the concepts which we have learnt so far. So, first question is that what are all the advantages and disadvantages of linked lists compared to arrays? When I say of advantage, as you know, linked list is dynamic in nature, so we can expand or shrink its size, and it is memory conserving. And the disadvantage of linked list, I would say that when we think of implementation, it's a bit complex as we make use of pointers, whereas when we talk of arrays, it is simple. And as you know, when we say insertion or deletion operation at end position, it is going to be simple than implementing the same with the help of linked list. The second question is that what is the time complexity of inserting a new node at the beginning of a single linked list? So, time complexity aspects, insertion is going to cost me the same amount of time irrespective of the position. And what is the difference between single linked list and a double linked list? So, in a single linked list you will be having only one pointer, and so that helps you to navigate in only one direction, whereas in case of double linked list you will be having two pointers, and so you can traverse the list in both the directions. And then what are the common operations you can do on a list? As I said before, we can do traversal, insertion, deletion. You can think of merging two lists into one. You can search for particular element in a list. You can do sorting of all the elements in a list. So these are all the operations that can be performed on a list. And then how could you traverse a circular linked list? So traversal, as you know, is visiting all the elements or navigating through all elements in a list. So as I said, you can either have a designated pointer as header and start from there, or if you are already at some position in a circular linked list, then as you know, in a circular linked list we can there is no end for circular linked list, so we can traverse in any we can traverse from the point where we are in a list and visit all other elements in the circular linked list. So in any real world scenario where a linked list would be a suitable data structure, so you could use linked list wherever we want. Say for instance, if you want to have a list of student records, then you could very well have or organize student records in the form of a linked list and use. So wherever we find arrays useful, in the same place we can make use of this linked list as well. The only advantage we gain is that it supports dynamic, it supports memory allocation dynamically, and thereby it helps in conserving memory space. Hope you would have understand the concepts which we have discussed so far with the linked list. Linked list being a linear data structure, it is dynamic in nature, and we have learned two operations on linked list, namely creation and traversal. I hope with the next few lectures we will be dealing with other operations that are supported on linked list.